Hello, everyone, and welcome to a CircuitPython Day chat with Kattni, Jeff, and Dan. We are getting together to talk about some of the best things in our own minds that we worked on in CircuitPython in the last year. Can be CircuitPython specific stuff or projects. We will see what everyone has to discuss. So I'm Kattni. I am sponsored by Adafruit to work on CircuitPython. I oversee the libraries, I oversee the community, and I write a lot of guides. So that's the majority of what I'm up to, but there's a lot of other things. Let's bring in Jeff and Dan.
Hello.
Hi. Who's going first? Go ahead, Dan.
So I'll reintroduce myself, right? Okay, so I'm Dan. I'm sponsored by Adafruit to work on CircuitPython. I work mostly on the core parts of CircuitPython, especially things having to do with keypad stuff and HID, but a lot of other things also. Those are just recent, and I did a lot of work on Bluetooth a while ago.
And Dan is also our excellent release manager. So thank you for releasing CircuitPython 8 beta yesterday.
Yeah, thank you. Please try out 8.0.0 beta 0. And if you haven't seen Scott's intro to what's in 8.0.0, including the web workflow, find that on YouTube to rewatch.
And I'm Jeff. I usually go by Jepler, and I've been working on CircuitPython for about 3 years now. And I usually work in the core, but I enjoy all the parts of it and seeing the projects that y'all put together out of the foundation that we create.
All right, excellent. Now you know who we are, so let's get into it. Who would like to get started? Don't everybody jump at once.
I'm straightening out my windows, so I'm not sure yet.
Oh, well, I guess I can talk. I had planned to have some demos of the camera stuff I've recently been doing, but I really ended up with just one. So if you can bring up my shared window, I will talk about this. Well, maybe I should have. Espressif has some cool little camera development boards. This one has the ESP32S3 on it, and it's got the camera up here and the LCD here, and you've got the live viewfinder. And the other thing that this demo does is when I hit the button, it is going to upload that image to Adafruit IO, which is my shared window. So if you want to come on back to that. And each time, if you want to see my desk here, it is an unholy mess. There's the desk. So it's a little camera that when you click it, it uploads to Adafruit IO, all using CircuitPython. And so while we were working on version 8, and there's kind of been a camera board in the we'd like to make it phase for a really long time. And a couple of weeks ago, Lamore said to me, can you look into whether we can support the ESP32S3 also? Because we initially did it with just the S2. And the answer is yes, because Espressif has a really good library for interfacing to the camera, which I created a wrapper around called ESP32 Camera. So it's a break from the past where we created one library that worked on a couple of different microcontrollers, but it gets a lot more capabilities, like support for about around 10 different camera types rather than the 3 camera types that I've been able to implement. And thank you, Dan, for keypad.keys. It was really easy to kind of wait for the shutter button to be pressed. And it's using the Adafruit IO library, so more boilerplate for that. And then once you get past the setup, it is a super simple program. Your forever loop, take a picture from the camera and send it to the display. Writing it like this makes it go faster than going through display IO because I wanted kind of the swiftest, silkiest refresh rate there on the viewfinder. And then if the shutter button has just been pressed, you change it over to taking a JPEG and encode it in the format that IO needs and ship it off. And that is essentially the whole program. Then you switch it back to the RGB format for showing on the screen. And so that is how easy it's going to be to do a project with camera and Wi-Fi in CircuitPython 8. and it should work on the ESP32 and the ESP32, the ESP32S2 and the ESP32S3. There's also this cool guy, which has the original ESP32. I have it, and there are some bugs, and I will be figuring those out hopefully in the near future. But getting this working is not as important as getting the board with the S3 working. We're really excited about that one. So Zarnlin asks, does this mean that the ESP32 cam boards will work? There's a common board on Amazon and other websites that calls itself ESP32 cam. I don't have that one. This ESP32 is from Espressive. It's called the ESP-I. And so those use the same microcontroller, so it might have the same quirks that are keeping this one from working. But hopefully we'll get that working too. I don't have one in my hands yet, but we'll see. And DJ Devon asked, would you be able to use Adafruit Bitmap Saver to screenshot output from a TFT to Adafruit IO? Yes, I think sort of. I'm not sure whether it supports the BMP format, and there's also limits on the file size of 100K. And so like a 240 by 240 screen, which is what's on this, expands to too much data to upload it to IO. So you'd have to make sure you're saving it as a supported image type and that it fits within the file size limitation of Adafruit IO.
So Jeff, what went into getting started with working with this camera stuff?
So where it started was on it started on a board with the Atmel microcontroller, and then it went on to some other boards. But basically, these modules are on Amazon and other websites with this particular pinout on the back. And originally, what I did was I read all the data sheets and learned the exact sequence of commands to send out to the camera to configure it and all this. And with the ESP32 camera, it's like you didn't have to know that at all because their library had already put all these parts together for you. And in particular, supporting each different camera's initialization steps, there are hundreds and hundreds of lines of data of commands and configuration you have to send to the camera just before you can get the first image out. And being able to use somebody else's library to do that was really helpful. So, yeah.
It was like weeks. It was
it took a
weeks
long
versus
time.
1 week or 2 days or something, right?
Yeah. I mean, the fact that I was doing this now for essentially the 4th time, because we did it on 3 different microcontrollers and then we redid it on Espressive, that made it go much faster. But just starting with a good library rather than starting with a data sheet is a huge difference in how long it takes you to do something. But, in any case, doing it in your Python code is going to be nice and fast now because you just have to write a few lines of code. So you have to configure the data, clock, another clock, some more control signals, and then these come from the board definition, so that's easy if it's designed to have the camera built in. And then, what kind of picture do you want? How many pixels? And then these other things that you just have to have. And then you can do things like flip it, mirror it, do some color effects, basic stuff. And so the other demos I was going to have were going to show how you can read QR codes, which I had tried to demo on this device, and this device was misbehaving. And then we've got some stuff for taking animated GIFs, which is also fun. And then you can upload them to your TikTok or whatever it is that kids do these days. I'm not clear on what you do next with that. So that's me and cameras, and that's kind of foremost on my mind because it's really new code from just July and August, and I've been having a good time playing with it.
That's excellent. What else have you been working on?
What else have I been working on? Well, this is a little 30-key keypad, and although the guide I actually did was using it with QMK, it is super to set it up with CircuitPython and just use it as a macro pad. Also, you can unhook it and it's just a fidget item. So yes, those are the ESP32 cams. Zarnlin was sharing a picture in the Discord chat. I hope those will work someday. They don't work yet. We'd love help from somebody who can sort out a weird, impossible error that happens when you're running Python code. The camera module itself, the image comes in. It's just the boards that I've been testing, the ESPi, are just unreliable. They give impossible Python errors, like can't assign to int when you're assigning, when it's not even aligned with an assignment. So the error doesn't make any sense yet. And that's where I left it last week before I took a week off. And I feel like I got diverted from the actual question. What else have I been up to? Well, let's talk to somebody else, and then if there's time, maybe come back around to me.
No problem. Dan, what have you been working on?
So recently I've been doing a lot of bug fixes. For 8.0, we have kind of a laundry list of things to do. And before that, I spent quite a while trying to figure out why there were issues with the matrix portal, which would crash after a little while. And that was a whole debugging saga. But it turned out there was a very small and intermittent race condition inside the code where we should have locked something that we didn't when we were sending it something to the SPI device on the board. So that's all done, and now I'm just knocking things off. But in the past year, what really has happened in the past year is that I did spend quite a while on Async IO, which is a way of having multiple tasks run in your CircuitPython program, so that you have things that run independently and take turns running, and you don't have to like often when you're doing something in CircuitPython, you end up writing like a big loop. Okay, part of the loop will read some buttons, and then you might do some animation, and you might write to the display, and you often have to like check for things inside other things if they take a certain amount of time. For instance, if you're doing some NeoPixel animation, you might need to check every time around the animation to see like, well, did somebody press a button, to see whether something went off, and it tends to make for spaghetti code. So Async IO is a way of doing something called cooperative multitasking. And Kattni, if you put up share my screen briefly, I'll go really directly to a picture. This is from the Async IO guide, the cooperative multitasking in CircuitPython guide, and somebody could post that in live broadcast chat if they like. So the basic idea with Async IO is that there are these tasks that run, and they all run in the same Python program. They're not threads, they're not separate processes. They're just basically functions that run. And only one of those tasks runs at a time. There's a scheduler that manages those tasks. And a task is either running, only one of them is running. A task could be ready to run, so that when task one in this diagram says, okay, I'm done temporarily, let somebody else run, the scheduler will say, oh, let's who's ready to run. Oh, let's run task two. Or a task could be not ready and it's awaiting something. It's waiting for something or other, and we don't know what. So the scheduler would say, like, when task two finishes in this diagram, if it'll see whether task three is ready, and if it's not ready, it'll go back around to task one. So the scheduler is doing fair scheduling of the three tasks. It's doing them in a round-robin manner, and the tasks always take turns. And what cooperative means is that these tasks are being nice to each other, and they're not hogging the processor. So they take turns, all right? Just like we take turns talking in here. And when one is done, it'll say, I graciously give the floor to the other task to let it run. If the task is greedy, it won't let the other tasks run, and then then you need something called preemptive multitasking, where the scheduler says, stop, I command you to stop, or I'll prevent you from running and I'll let this other guy run. And that's what happens on your your Windows or Mac or Linux computer, is that there are a whole bunch of processes running, and there's a scheduler that keeps interrupting them. And they don't give up control. They just might get interrupted so something else can run. But in the cooperative world, you assume that you wrote the program, so you know how long things take, and each task will take its turn and then go on and move on to the next thing. So let me switch to another window here. Let me just change what I'm sharing here. Hold on. Okie dokie, if you can put that one up. Kattni, thanks. Okay, so this is a very simple, and I'm looking off to the left because I have two screens, so it's not that I'm ignoring you. This is a really trivial program. It's kind of in either this exact program or a similar one is in the Async guide, Async IO guide, so you can follow along. And what this is doing is there are two tasks that are running. They're each blinking one LED. And unfortunately, my desktop camera doesn't work, so I'll just have to hold this up. But there are two LEDs here. And if I reset everything, I don't know if you can see that. Are they blinking at different rates? I don't know if you can see that or not. But they each blink for a certain amount of time, and they blink at different rates. I don't think you can see it, but sorry. Okay. So what's happening here is that there's this blink in the program. There's an async IO, an async function called blink, which takes which pin to blink and the interval between blinks and how many times to blink. And it's just turning an LED on and off. And in between this interval, each time it does something, it says await async IO.sleep for the interval. So the interval is like a quarter of a second or 0.1 seconds. This one is quarter of a second. This one is 0.1 seconds. And so when the program gets here, this async IO.sleep, it will give up control back to the scheduler. So the main program, what it does is that it creates two tasks, and each of them are basically an invocation of this blink routine. And then we say, let's run both of those using this gather function. And they'll run, the scheduler will run one and then the other. So we'll run LED one task. It'll turn on the LED and then go to sleep. And then the scheduler says, oh, great, I'll let the other person run. And it says, I'm going to go to sleep for this amount of time. So it lets the other one run. That one turns on its LED. And then it goes back. It gives up control to the scheduler. And the scheduler says, hey, is LED one task ready to run? And it says, no, the sleep time hasn't occurred yet. Okay, well, I'll go to the next one in line. Is LED two task ready to run? And it says, no, the sleep time hasn't elapsed yet. So the scheduler will just wait until the sleep time for one or the other has expired, and then it'll let that one run. And so what will happen then is that the LED will get turned off, and again, it will go to sleep. So these two things are running completely independently, blinking at different rates, and they don't have to know about each other, and there's not one big loop where we have to keep checking what time it is and has the time elapsed for one or the other. So it's a really nice way of breaking apart things that need to run independently. And this is like the most trivial example, but you can use this for all kinds of things that need to run independently. And you can write, for instance, we don't have this yet, but we're going to have like a version of the requests library, which does Wi-Fi requests. And it will say, okay, I'll make a web request, and then I'll go back immediately, and you can wait for the web request to finish, but in the meantime, another task can run. So for instance, you could, if you're talking to a slow web server and you don't want to wait for it, you want to do something else in the background, like talk to another web server or do an animation or something. or update the display, you can do that. And then when the task that's waiting on the web request finishes, or when it gets the request, then it will go ahead and be ready to run. And this will work out very nicely, we hope. Async IO has been in Python for a long time. It was originally put in to do network programming. So that's kind of an example of what I was talking about. But there are so many other uses for it when you're talking to external devices, which wasn't really a consideration for regular Python, for CPython. So that's what we hope to continue developing things. We need to make more and more things be sort of async capable. And Jeff recently did some work to make the keypad module be more friendly and more async capable and be able to run faster. So, which is way down in the depths of how these things work. But we hope to make that work out better. So this has kind of been on hold for 8, or my work on this has been on hold for 8. But once we get 8 out, I hope to come back to this and do some more things that and have more examples and write more libraries that are async capable.
Hey, Dan, try holding it up again, except hit reset once you've got it closer to the thing. Right. I didn't have you big at the time, so.
Okay, let me just see if I can get this.
Perfect.
Wait, no, let me press reset. It's not blinking.
Mm-mm.
No, I think a wire fell out or something.
Yeah, so I kind of researched.
Oh, I know why it's not, because it's not code.py. All right, hold on a second.
I researched into what does it take to make an object in the core be something that you can apply that await keyword to. And the answer is you can't quite. You still need a little bit of helper code written in Python, but I was able to understand enough so that everything in the keypad library, there's a very small wrapper you can put around it that makes it awaitable.
There it goes.
And so one thing that means is because keypad.keys will sense when the key is pressed and when the key is released, it is a lot like having an interrupt, quote unquote, because after the signal goes from high to low, that await, an event will go in the event queue, and then the await will return because there's now an event available. So this is very close to what people are asking for when they asked for interrupt pin support in CircuitPython. It's not technically an interrupt. It still is pulled every X number of milliseconds by code in the core rather than being a true microprocessor interrupt. But it lets you wait for a change on a pin and come back to your code in a very efficient way. So I'm excited about that addition, and kind of the way that I did that, I think we can extend to other items. The other element that we need here is some kind of wrapper library that you could import that would make it easy, not make you have to individually write that Python wrapper code each time. I will drop a link about that little feature in the Discord chat, and I'd love to hear what anybody thinks about that or thinks would be good to add in that respect.
I really appreciate Jeff working on this and like looking at the guts of the insides to see how it should work. That was wonderful.
So Dan, a lot of work went into implementing Async IO. It seemed like a lot of that was you working to understand it. How did that go for you?
That was the hardest part. Yeah, because Async IO, as used in regular Python, people have complained about it a lot, and because it is very hard to understand. And I myself didn't bother to try to understand it. And then I found some people who had written libraries that aren't Async IO. Async IO is just one way of doing asynchronous cooperative multitasking in Python. And there's another library called Trio, which was kind of more structured and easier to understand. And once I read that, then I really understood what was going on. Unfortunately, we can't have Trio in CircuitPython. It's too big. But there's a key part of Trio called task groups. That is a very structured way of using tasks. And that's going into Python 3.11. And there's also going to be a version in MicroPython. It's really just something that you can implement in Python. And so we expect to adopt that really soon. There's some features that were added to Python 3.11 that have to do with exception handling from multiple tasks that are really complicated, and we may just omit that because it's kind of complicated and not really that necessary. But so what I had to do was understand Async IO well enough to write a guide, and that's basically how I educated myself and how I came up with the simplest examples that weren't tricky. And all the CPython examples I found were more complicated than what I put in the guide. So the guide is really the result of me trying to make it as simple as possible for myself and then explaining it to you.
The regular emphasis, you've said this a couple times about Async IO and desktop Python, is networking. At PyCon 2022 this year that I attended thanks to Adafruit, I attended a talk where somebody was talking about it from the point of view of creating a video game in which each actor in the video game was a different async def function. And to me, that was an interesting talk because that corresponds a little more to the things you might want to do with async in a CircuitPython program. You've got a sensor, or you've got a button, or you've got an LED, and you want to think of them as independent things leading independent lives. And so it kind of fits into this mold of I'm using async to talk about the objects in my video game. So I will also find a link to that talk and put it in the Discord chat because it was a non-networky way to think about it. Although the particular presenter had their own async library, like you were talking about, Trio is different from Async IO. So it doesn't directly translate over to CircuitPython, but it's definitely a good way to think about a reason to use coroutines.
Right. And I think, yeah, what's really going on, the way this stuff really works in Python is that Python has coroutines, which means that in the middle of a routine, you can temporarily return a value, or not temporarily, but you can return a value. And then when you call the routine again, it starts up where it left off. So really, that's kind of like a task. And that mechanism was adopted to make Async IO, but it was really used for another purpose. It was used for generators and stuff, and it was kind of repurposed into cooperative multitasking. And because of that, a lot of the early work on Async IO in Python was very ad hoc. And there were a lot of things about passing data around that weren't understood well and so forth. I mean, the key to making things, when you have multiple tasks or threads or processes running, the key to not having a lot of problems is to make sure that they're not sharing a lot of state. Because if one thing changes something, the other one doesn't expect it, that's where the bugs come from. So in threads, this is especially bad because there's no control over that. And in Python, unfortunately, there aren't that many globals, so you can avoid that. In processes, if you have multiple processes running, they share state, usually in the file system, and sometimes there's a race condition there. So the key is always to avoid sharing, to share as little state as possible.
And if you're not on our Discord, you should join us and hang out. But the title of the talk is Why I Re-Implemented Trio in a Game Engine, and it was presented by Daniel Pope at PyCon 2022, PyCon US 2022. Good talk.
Okay. So I think we could move on. Kattni, I'd love to hear about your Mailbox project. This is a great project, which is not like what kind of project we can make, but this project was inspired by a real world need, which is the right way to figure out how to do something and you know what you really need to do. That's great.
So this whole thing started because a year and a half ago, maybe 2 years ago, my dad said, "Hey, I'd like to know when I have mail in my mailbox. Can you make a flag or something that stands up, and then I can look at it with the binoculars and see it?" And I said, "Nah, I can do way better than that," and did nothing about it for quite a while. The way that their place is set up is the mailbox is about 800 feet from the house. So, and there's trees You can kind of see it from certain places, but there are trees in the way. And so walking all the way down that driveway to get to the mailbox and check it and not have mail was annoying. So that's what this came out of. And so I wanted to do something where when the mailbox door opened, something would send a message to something in the house. The ideal situation was to send a text message to his phone, but I will explain in a bit why that didn't work. But I wanted to be able to send something, a signal to the house that said, hey, there's mail. So the easiest way to do that, as far as I understood it, was using LoRa, which is long range radio signals. And we have plenty of LoRa boards for different microcontrollers and different for Raspberry Pi as well. And the process was, or I figured use a Raspberry Pi as the receiver, mostly because it can handle that kind of code. It might be a little bit overkill, but the LoRa bonnet, which is for, well, it works on any Raspberry Pi, but it's designed to fit exactly on the Raspberry Pi 0 or 0W or 02W. So I wanted to use one of the smaller Pis so that it wasn't overkill, like real overkill. And by the way, thanks to Carter for sending me 2 Raspberry Pi 0Ws. I have a bunch somewhere. I have no idea where they are. I've moved twice and lost them all. And Carter had a couple sitting around, so I was able to move forward with this how I wanted to. So I don't know anything about LoRa. I still understand very little of it. I get the gist of it. It's sending signals and so on, but I certainly didn't understand the code, and I didn't understand how to write the code. And I knew of one community member who was really interested in it, and I thought that he would be able to write the code. So another thanks to Jerry for helping me out with this. The code that he wrote, well, let's talk about the hardware first. I used a Feather ESP32S2 because that was the only board at the time that had a battery monitor built into it. So I didn't need to add an extra board for that. And the LoRa Featherwing. And on the Raspberry Pi side, I used the Raspberry Pi and a LoRa bonnet, which has a display on it, which is super handy. Other required it's powered by a battery or a solar panel. There's a let's bring it up actually. Let's do this. Oh, that didn't work. Hold on, let me try something. Nope, doesn't work. Okay, so we're going to do this mode and do this. So here is, it's gonna knock everything out of the way, but and of course it set it off. So this is the solar charger. It is a breakout board where you can plug a loadout, which is the Feather, and a battery into it. And then on the other side, you plug in a solar panel with an adapter. And I wanted it to be able to sort of run on its own and not require external power like from USB or anything like that, as it was going to be attached to a mailbox, 900 feet from a house. And it also requires a normally, hold on, I wrote it down. Normally open reed switch. Reed switch concepts are confusing. They're not really intuitive, but the normally open is a crucial thing because the CircuitPython code uses pin alarm to wake up when the signal is sent, and that normally closed isn't supported. I tried to make it work, and it didn't work, and it turns out that's just we don't support the concept at the moment. So that's a crucial thing. I also attached a giant chunky LED to this bonnet, which I don't want to unplug the Pi because it's working right now. So as soon as I demo the actual thing, I can take the Pi off and show how I attach the LED because it's kind of ridiculous. And so when the mailbox opens, which is this switch is mounted to the mailbox and the mailbox door, it sends a signal, it sends a packet to the Pi, which is waiting to receive at all times. Well, it wakes up the feather, sends the signal, and it shows on the display, which my dad asked specifically for it to say "You've got mail," which didn't quite fit, so it's just "You got mail," and the LED blinks. So it's got both, it lets you know on the screen, but also from a distance you can see the LED blinking from the other side of the house. So basically, I open this switch as though the door has been opened. Sometimes it takes a second for the signal to be received, and there we go. So the display says, well, now it says mailbox times 2. And what that means is that it thinks the switch is open twice. I think that's because the feather reloaded in the middle of this. I've got the serial console open, and it did the reload. But that tells you maybe that you've gone and gotten the mail and opened the door yourself. And then you can reset it by pressing any one of these buttons. And if you leave the switch open, obviously it continues to send that packet, and so it would receive it immediately. But now I've cleared it. And the little bit that shows up on the bottom, the top, the artifacts on the top, we never quite figured out why those were happening. But this little bit that shows up on the bottom is the Wi-Fi signal. We just wanted to have an indicator of that on the Pi so we knew what was going on. So let's talk about the build. So I'm going to unplug this so I can take the bonnet off of it without causing problems. The Pi requires headers. So that's part of the soldering for that. You want to get, well, actually it really doesn't matter. You can use single row headers and just put 2 of them on there. But you would want to solder the header to the Pi. And then this big LED, I wanted to be as compact and flush as possible, which I received several suggestions as to how to mount the LED because the LED needs a resistor, and none of them quite fit what I wanted. So I did a super hacky workaround with this, and the positive pin is connected to a pin, the TX pin specifically, because all the pins of the Pi are broken out in this row. And then the ground side of it is actually shoved through, let's see if I can get this to focus, probably not, the mounting hole. And the resistor is connected to ground. It's bent weird, and the 2 pins are connected. I put a piece of Kapton tape, which is high temperature polyamide tape, and it is not conductive. And I put that across any pads that this might have touched just to make sure I wasn't sending errant signals. And it worked great. And it made it so that it was very much not sticking up higher than I needed, and there's no extra hardware on the top. Definitely not necessary, but it was a good workaround for me. In terms of the feather, this is the LoRa feather wing. It does require you to solder these wires, which the guide for the feather wing has on it options. Apparently, there are multiple options for the Feather ESP32S2, but this is the configuration I went with, mostly because it's what Jerry suggested. And you want to run whatever the ground line is from the reed switch to ground, which is wacky right now because this is actually the ground line, the white one, and the black one is the signal line, which is backwards in my brain. So I had to double check that about 16 times. And it's just plugged in using female headers on the feather. Now for powering, there's a couple things. The solar panel itself requires an adapter to plug into the charger. And there's 2 adapters available on Adafruit, but this one has this basically this bit here that makes it, I can't even do it with my arm straight out. The bit that sticks out past it actually clips right over the plug, and you have to push it in there hard, and now it's sealed. So I didn't have to actually seal the solar panel cable. The adapter did that for me. So this was a great one. And because the feather has charging circuitry on it, because it will charge a battery if you plug a battery directly into the feather, to avoid any chance of the charging circuitry trying to work over top of the solar charger, you need a JST to JST cable, and you need a Schottky diode on the power line, basically. So I kept this one visible to just show what we did, and because it's the cable is the same on both sides. Even if you plug it in backwards, it just won't power it. You won't break anything, and then you know to flip it. And then this amazing USB-C solar charger, it worked great. It's difficult to show here because I don't have a window close enough to put the solar panel into. But I used a smaller battery, one size down from this one, in the actual one that is mounted on my dad's mailbox. And because of the fact that there was such a distance and things that could interfere, I included an antenna, which I don't have extras of, so I can't show it, but it's a black antenna that is an option if you need more signal, but you can actually attach a wire of the proper length, which the guide covers that as well. And as long as the wire on the Pi and the wire on the feather are oriented in the same direction, it works really well. Right now, there's no antennas attached to these because they're literally 2 inches apart. One thing I will say is to attach that the black antenna that has the little connector on it to the feather wing, you have to solder this tiny connector to it. I didn't do it. I had somebody else who solders better than I do help me out with that one. It's very tiny, and I'm sure it could be a pain for some folks to do because soldering a wire to these pads is much easier. So give that a try first, and then worry about adding an antenna if the signal is an issue after that point. So I also got one of the small clear top project boxes that Adafruit sells, and drilled holes out for the antenna and the solar adapter, and then sealed those with a silicone sealant. And that is in the switch as well. And we had to extend the wires on the switch quite a bit to get them from the project box to the door. And it worked. My dad wanted, we initially had all these other ideas, let's have it send a text message, let's have it send an email instead. It turns out there's this registry now that you have to, if you're going to try and send a text message to any major carrier, you have to be part of this registry, and it costs a bonkers amount of money. And things like Twilio, which you used to just be able to use that service to send an SMS, don't work anymore that way. This is as of March 2022, I think. So we ran into that, and that was like we couldn't figure out why everything was crashing and why it wasn't sending. And we finally figured that out. And then the email thing we just never got to work. And I wanted this built for Father's Day, so I had a deadline, and I managed to almost meet the deadline. I had it mostly done, but basically, when it was all said and done, my dad said, this LED is working for me. Can you just make the code not do the rest and just have it blink the LED? And I said, yes, we can absolutely do that. So this is what we ended up with. I used 3M Command adhesive Velcro to mount everything in the project box so that if you need to remove anything, it's removable, but it's held solid otherwise. And I guess, that's it. We thanks to Jerry for the help, and thanks to my partner Rose for help with the Raspberry Pi code. The code that Jerry wrote handled the signals. That was the basic code, and then we needed to add all the notification stuff, and that was a little outside my wheelhouse to do actual Python code that had all the signal stuff in it and actually had the notification stuff in it as well. So Rose did most of that as well. So I had a lot of help with this, but the build was all me. My dad actually rebuilt the whole base for the mailbox to handle the solar panel on the back of it, and where we could mount the project box as well. And so that was a lot of fun.
So for wireless, the CircuitPython
Muted,
board is
Jeff.
using LoRa, not Wi-Fi, right?
Say it again.
For the wireless from the CircuitPython board, that's using the LoRa and not Wi-Fi, right?
Correct. The Wi-Fi was superfluous to this project. I wanted the battery monitor, and that's why I went with the ESP32S2. It's every bit of signal coming from one to the other is using LoRa.
Let's see.
So I could go over the code a little bit if
I've never seen LoRa code, so
okay. Let's take a look. Let's see what happens if
I think it's interesting also is that there are so many design decisions in here. Like there's kind of the UI of the whole thing, and whether the two boards should like exchange information or just should be one way. There were so many design decisions beyond just like, there were so many things that caused you to make certain decisions. And I think that's interesting for a project, even a project that you might say, quote, oh, this seems really simple, but in fact, it's not simple at all. And to get what you wanted to do, to get it to do what you wanted to do reliably. Yeah.
And yeah, that's interesting you mentioned that. My partner's really bad about scope creep, which is a term for continuing to add features beyond what you actually need, beyond the minimum viable thing. And so when it came down to it, I had to very specifically say, only this, just add that. I don't want anything else, only this. We've worked together previously on the LED animation library, and the API for that was entirely my doing, and a lot of the code was hers. So we've worked together in this way before. She's much more fluent in Python than I am, so it's always a good collaboration there. But yes, for sure, there was decisions on exactly what I wanted it to do, and then obviously what I wanted it to do was one thing, but then once it was in my dad's hands, like what does he want it to do, which is really ultimately what I needed to provide. And so, that's when he was like, well, I'd like the message to be something else, or I'd like just the LED to blink. And so we did all that around what he wanted. So let's take a look at, let me remove this. There we go. Let's take a look at some code. So I have the Raspberry Pi code as well, but that is, like I said, a little bit outside my wheelhouse. The CircuitPython code, I understand for the most part. So we'll go over that instead of the Raspberry Pi code. All this is available on GitHub. I will drop a link in the chats when I am done. So basically, and again, I don't quite grasp what alarm does. One of you may be able to help me with this section here. But we set up the battery monitor, which is built into the Feather, and that allows us to get the battery voltage, and that appears on the Pi display when the notification shows up. And that way, if at any point it has dropped significantly, we know we need to check on wiring or reposition the solar panel or something like that. We set up the little red LED here for informational use later. And the alarm pin is what the read switch is connected to. So basically, when that switch is separated, it sends a signal, and that's what we wanted to capture to wake it up, because we wanted this whole thing to go into deep sleep when it was not in use, so that it's using very little power. The idea being that if the solar panel isn't working, is covered up, or it hasn't been, very light out for a while, it would still be able to run for a very long time. And so we need a pin, obviously, to wake it up to be able to send the signal at all. This is LoRa related. This is setting the frequency. It turns out, if I understand it properly, in the US, only 900-ish megahertz is allowed. Is that right, Dan?
Yeah, without a license. Yeah.
Yeah. So that's a standard thing. That would be anywhere in the US. And then this is standard, I want to say, in Europe and elsewhere. But check and make sure that you have the right LoRa board, and that you put that in your code for your local area. And then the RFM chip, which is on the LoRa Featherwing, requires some setup as well. And this says apparently send a message as long as the pin is low. Now, the way that the packets are sent here is as a byte array, which there's 3 different versions of the code that Jerry wrote for me, and I don't recall what the other 2 do. But they send the information in different ways, and it's just it all is allowable. The Pi can receive in multiple formats, but this is the one that we went with. So basically, the reason it's not pin.value is the way that the normally open switch works. It sends false when it's separated. And this is what we are sending. The important bits here are these sections here, and then which again, I'm not entirely clear on what alarm.sleep memory is doing, but this is the things from the battery monitor, which allows you to send the voltage and the battery percent. And to be clear, this is only happening while this is open. So if you were to run this code with the switch closed, it'll hurry through it and go to sleep. And then it will wait. So this is the sleep code here. But when it opens, it then sends a packet to the Pi. If it doesn't receive an answer, it prints this, it hits this, and then I believe retries. And that would be if the Pi is not on and present and waiting to receive. And then sleeps a bit. And we deinitialize the pin here. So I think so that whatever signal is sending is fresh. And then we put the RFM chip to sleep, and then we create this pin alarm, and that's using the pin that we attached the read switch to. The value when we want the alarm to signal, which is why it gives false when it's open. So we want it to send on false. And this, because the pin requires a pull up, I think this is true. And then it goes to sleep. It goes into deep sleep. If it's connected to USB, it pretends to go into deep sleep. If it is not connected to USB, it goes into actual deep sleep. And it waits until the pin alarm happens, which is when the read switch sends a signal, and then it starts all over again. And like I said, it will only run this bit if the switch is closed when the code initially runs. So it would just go straight through it and then go to sleep and wait until the switch is opened. And part of the reason I wanted it to work like this is the important thing was to have it run for as long as possible without needing to be charged, because charging it would be kind of difficult. We have to remove the thing from the mount and like all this other stuff, and you got to open the box and plug things in and so on and so forth. So I didn't want it periodically sending information, which was one of the things that was initially discussed, was periodically sending the battery information. And I'm like, that's just really a waste of power, energy rather. And so we didn't go that route. It only sends when the box is open, which obviously if the box got left open, it would continue to send. But it tracks, let's pull up the Raspberry Pi code. And that worked. All right. So there's a lot of import stuff going on here. I actually have no idea what some of this is, but we get into if you recall, this is the LoRa bonnet, and it's a very similar setup to the Feather. You don't have to do those wiring connections. They're done automatically, but it's the same frequency and will require similar setup. This is for the little Wi-Fi indicator that's on the Pi screen. This is the message that it shows when there's new mail. This is when the door opens multiple times before it's reset. This sets up that little blue LED, well, kind of chunky blue LED that I put on there. And then because there's stuff that uses I2C, the display, you set up I2C, and then you set up the display. There's a lot of code here that clears the display and then shows there's a blinking dot that tells you that it's running. That sets that up. And then this is the pins that are actually connected to the chip. The bonnet has 3 buttons on it. At the moment, they all do the same thing. But this is the setup for the buttons. This is basic button polling and a debounce on it. Here we initialize the SPI code and set up the RFM chip. And then we get into a lot of stuff that this is the part where I'm fuzzy, but this talks about the packet. I think it actually sets it up so that it can count the packets, and that's how it knows multiple mailbox opening. This is the state of things at any given point in time. This is for the Wi-Fi signal bit, and this draws the Wi-Fi signal bit, which this is just a lot of display code here. This checks this blinks the LED or this blinks the LED, but this is when to blink the LED. And the interval, which obviously can be customized. This is the Wi-Fi, getting the Wi-Fi strength at any point in time. This is where it's getting packet information, and that's what is being sent from the feather. There's some try and accept going on here because you don't want if a partial packet is sent or it only receives a partial packet, you don't want it to crash. So it logs that it got an invalid packet, but it doesn't stop the program, which is what we, you want to avoid if it's something you want to just leave running long term. This was from us trying to use Adafruit IO to send an email. We just didn't get a chance to really work with it. But this was the initial start of that, because Adafruit IO can send emails based on triggers, and we just never got a chance to really set it up. And then my dad said, please just make the LED blink. So we stopped that. This is checking the buttons. And so that whenever one of them is pressed, it uses that to clear the notification. This is what is used to display the text for the mailbox message or the more mail message. This updates the display. Again, this is just standard display code. This is to make the display blank, handle the packets. Once the mailbox is triggered, it sets this off. This is when you clear it. I think that the Pi can also look for information, and that's what is going on here. This is where the buttons, if any of them get red as pressed, it clears the notification. I don't have it up right now. There's no point in demoing it. And then this is if there are packets, to get them and then update the display to show the more mail thing. And then the mailbox sequence is that if there's a packet available, you trigger the things that we just talked about. It sets up the buttons for read and the packet, whether or not there are packets in the queue. And if they're available, it runs this. If there's buttons, it uses the button handler to verify that the buttons have been pressed. Here is the button handler. This updates the different flags, which are that when the mailbox was opened, was it opened, the last battery percent, and the last packet data. This, I believe, is the it has to do with the LED, if I remember correctly. And then this uses threads, which are way outside my wheelhouse, so I will not be able to explain what's going on here. But the idea is that it's looking for packets. It's waiting to blink the LED when the mailbox is opened. It has to continue to check for signals so that it can say that it's now been opened twice or 3 times, etc. And waiting for the buttons to be pressed for it to clear. So there's a lot of things that it's trying to do at the same time. And that is what it does. And then here's where everything is running. So this is what's actually running the code that we just went through. Apologies for the very vague explanation of this, but this is definitely code that I had help with. So basically you're always looking for a packet on the receiver end, and you're sending packets on the sending end, and that is basically LoRa code with a sender and a receiver. I don't know if there's actual terms for that or not, but that is what it looks like.
I was going to jokingly interrupt you and ask if you were going to use Async IO, but then you talked about threads. So
yeah.
So with the deep sleep and the sleep memory, basically when the deep sleep finishes, it's like almost everything about your program was erased but these items within the sleep memory specifically are kept. So that's how you communicate with your future self after waking up.
Okay, that makes a lot of sense. This is whether or not it woke up then?
So yeah, that first block, the if at 9, it goes into line 10 if it woke up, and it goes into line 13 like it was just plugged in.
Okay.
So it's, do I clear out some things that I remember, or do I increment the count of something? So 0 looks like the count of ever woke up. And I think 1 is the count of ever saw that the mailbox was open, and 2 was the count of ever had an error transmitting or failed to get an ACK or something.
Yeah, that sounds about right. And then here, it's sending that information within the packet that is getting sent to the Pi. And then this is also where it's incrementing that error.
Right.
Which makes sense because you don't need to keep that on wake up. So I understand why it would be cleared at the top. And this is incrementing I think the mailbox status, like has it been opened, and how many times? That's how many times it's been opened.
Yeah. So one way to make that a little less
obtuse.
That's a good word. Is sleep memory you have to use the brackets and the number. Although I think Tim wrote a nice library for doing nicer than that.
Okay.
But you could also just give names to the 0, 1, and 2 values. So you could say number of times opened equals 1, or whatever it is, whatever name you want to give to it. I don't know if that's the right meaning. And then instead of in brackets 1, you'd say in brackets number of times open.
Oh.
And then it would become more self-documenting.
I follow. Okay.
Each time you have the 1 in brackets, you change it to the named thing in brackets.
So you're just setting a variable.
So you're just setting
0,
a variable.
0, 1,
what
and
it does
2.
for you as a human is it helps you understand.
Okay, I was tracking for a second there. I thought you meant the whole alarm sleep memory thing. You name that something else.
No, just the part in brackets. You give it a name, and then it's like self-documenting.
Yes, much more human readable. That is a great suggestion.
But other than that, I mean, it's nice compact code that does what it needs to do.
Yeah. And I'm really happy with it. I had not. I built this yesterday. I didn't I obviously don't have the original.
The demo version you built.
Yeah, I've got this secondary prototype, and I soldered everything up, and the Feather already had the code on it, and so did the Pi, or a version of the code. I plugged it all in and it just worked. So that was really excellent. We needed to update the Pi code because the Pi code was like an earlier iteration that had a bunch of other nonsense going on. So we did that. But that is the thing. I swear there were a couple other gotchas that I ran into, but I have since forgotten them. I remember passing by and looking for the code, a document that said mailbox notes. I didn't end up looking at it, but that might have some of the gotchas. What I did do was I put it on GitHub and included in the README all of the parts necessary with links, except a link to the Raspberry Pi because you can use whatever one you want. And I didn't put a link to the read switch either because, again, they're all over the place. But I put all the parts in there and the options for antennae, and then also tools and extras required, because you're gonna, if you want to actually put it in a project box, you're gonna need a power drill to be able to obviously drill through the project box. What I would recommend, which is not the greatest thing because it means wasting one, but get 2 project boxes and practice on one. I was really glad I did that. I wanted to know whether I could, drill really close to the edge and like all this other stuff without shattering it. And that really worked out. It does mean potentially wasting a project box, but if you manage to drill through the first one perfectly, you don't even need the second one. But it definitely would give you an option in case you mess up the the drilling at any point in time, you can, you know, practice it again and try a different side of the box or something to that effect. Any solar panel will do with this particular connector on it. Adafruit sells, let me add this back in. Adafruit sells a bunch of these. There's a different one that I used, and I linked to the different one on GitHub. But if you go to that page, it actually lists a huge number of them, and the one that I used is no longer in stock. But the one that I use is no longer in stock. But the other ones, there's a ton of other ones available. And there's another solar adapter that has a wire on it. Again, that one doesn't have the seal clip. So, and also for whatever reason, it didn't fit right, which was something I ran into and actually almost didn't, because I had to order parts at the very last minute. It doesn't have the little bit that clips over to make it waterproof. So I kind of highly recommend using that little L one. It does mean drilling a larger hole through the project box, and it's a very weird size. I needed a 29/64 inch drill bit, which is not included in a standard set, and I had to buy it individually. But I really wanted the right size. You could definitely go with something a little bit bigger, which is more standard, and still have the same effect. But I haven't documented the build. This was obviously a personal project, so there's no guide to go along with it. But what I'm hoping is to get some better pictures of the one that is on my dad's mailbox, which has the holes drilled into it and the sealant on it and so on and so forth, and at least post those on GitHub or something to that effect. So it's a little more obvious how the build went. That's the other thing. So Jerry built this as well. He mentioned it to his wife, and his wife was like, no, we really need that. So that I felt a lot less bad about asking Jerry for help with the code because he was also building the project. But he used a big project box, and I was like, I bet I can fit this. I gotta, and I had to Tetris it basically to fit it all in the small project box, but it did work. The battery's attached to the top because really like putting everything in the bottom is not necessary because you have extra, space upward. And the rest of the bits are Velcroed down, and then the wiring is kind of just finagled in there. That's what I'm hoping to get. That's what I'm hoping to get pictures of. C. Grover asks, unfortunately, Mailbox baseball is a thing here. Did your dad have to reinforce the final installation? So that has been a thing. I don't know how recently, but it has been a thing on my parents' street as well. And so it's mounted on a wooden pole that's about that big, and I think cemented into the ground. And then the mailbox is mounted on two boards that are about this thick combined, and that's what's holding the solar panel. And he has boxes for newspapers, which I think he no longer gets delivered, but the boxes are still there that are on one side of the mailbox. So we put it between the two boxes. So if mailbox baseball happens, it's going to happen from the opposite side. So it's really unlikely that anybody would damage the feather setup because there's like a protective thing outside of it as well.
You've got decoy mailboxes,
basically. So we had to get the antenna to sit upright. We had to put it on a block, and then there's a 3D printed mount that we designed to go with the project box, so you could actually screw the project box right into the mount and then put the lid on the project box, and it worked. But we didn't reinforce it beyond that. I asked him whether that was something he wanted to do or whether we needed to do it, like add a giant hose clamp or something to it to like keep it, keep it good to go. But he didn't think that was necessary, so we're giving this a try. So far, so good. But it's only been a couple months. We'll see how it goes, for the next however many years, I guess. And that is true. Brick mailboxes do prevent that. But my dad's is plastic. But the point is, it's mounted like lower on the pole, so damaging it would be kind of difficult unless you specifically stopped and just like hit it from the top. So that's kind of how we handled mounting. Link to the waterproof adapter. Oh, that one's been linked. Excellent. I will have to see. Obviously, project guides are up to folks other than me. So whether or not this will get turned into a guide is not up to me. I did not document the build very well, so I would actually need to order parts again and actually document the setup. But overall, it's actually relatively simple. So I think it would be a good guide. But we will see whether that ends up happening.
Well, congratulations, Kattni. Out of the three of us, you actually built a useful thing.
Well, I mean, you guys build stuff that lots of folks are going to be using. I mean, that's also excellent.
There's that word simple again. I think you underestimate how good you guys are. It's true that with a lot of practice, you start to underestimate how difficult things are for a newcomer.
Yeah.
But if you feel intimidated by this, I think my advice is try it for a while, and you'll find that things are getting easier for you too. And that's why, even though I've been doing this for a really long time, that's still the way it goes. I get better at things. And so, yeah, don't sell yourself short, and you'll get better at it.
And expect to make mistakes and expect to realize that you need to change something, because that's what engineering is.
I was actually really surprised I was able to replicate this LED soldering because I got it to work once and I thought I'm never going to get this to work again, which is why I insisted on using the original bonnet for my dad's version. But I was able to do it. It's a little bit cleaner on this one too. But there's only a few things that need to be soldered. The code would be provided in the guide and will be provided on GitHub, so you can even preview it long before any guide exists. And so as long as you have the right parts, it shouldn't, I guess I'll rephrase it, it shouldn't be too difficult, is how I will put it.
My colleagues at my former job used to say I had two modes, which is me going around saying, this is impossible, it will never work, and then, oh, it's done. And there's not a lot of in between, because it works or it doesn't.
Right. There's not a lot of partially working. You can say a couple features have been implemented, but if it works or it doesn't, yeah, that's definitely the case. Does anybody else have anything to add? Any more questions?
I've really appreciated the audience. They've had some excellent questions for us today.
That's true. We can also answer general CircuitPython questions. We do have a little bit of time.
A little bit of time. And thanks, Mr. Certainly, for keeping an eye on things all day. It makes for a long day, and we're glad to have you back there. And everybody else, I don't know the names of everybody who's probably behind the scenes on this, but thanks.
Yeah, we have Kelly, one of our internal folks who's been keeping track of things as well. And obviously Phil of Adafruit fame has been keeping an eye on things too.
And thanks to Anne for all the blog posts as we put this together. Thanks to Kattni for putting together the schedule and making it work.
That was a bit of a beast. A lot of people had different requirements. So we had to, I wanted to work around and make sure that everybody, had something that worked for them.
How many years until we've got so many people that it's CircuitPython week?
Well, I mean, today was full. That hasn't happened yet. So
Yeah.
we've at least reached the time that we have filled up a day. And the next stream, actually, which starts at 6 p.m. Eastern, which is 40 minutes from now, will be going for a few hours. So good on Tim for having the stamina to keep folks entertained for that long. But we basically had video content from 11 a.m. to about 9 p.m. Eastern. So we filled up a full day, and obviously if we've got anybody else next year, it'll have to be either shifted to CircuitPython days, or we'll have to have synchronous video streams going or something like that to
Or
get
more
everything
use of
out.
world time zones. I mean,
Also,
if
that
y'all
would.
are in Australia or Europe or Asia, we can extend it to the full world time zone. We'd love to have more international content too.
Yeah, that would be excellent. We had a Spanish-speaking show and tell last year, hosted by Alvaro, who's on Discord as Fitted too, and that was excellent. So definitely understand that like that sort of opportunity is available. We were able to do that at a time that worked for the host and so on. And we can accommodate a lot of things. So
yeah, well, our snakeologists are probably already studying what is the snakiest day of 2023, but I think there's a good chance it'll be August.
I think so too. It's twofold. One, it kind of works out. Two, there's no holidays in August, and Adafruit provides a paid day off for Adafruit folks at headquarters for CircuitPython Day. So having another day
Not for
in
us
August.
though. We
Well,
get to work.
we're here. It's hardly work though. So that's an opportunity for that as well. And since there's no other holidays in August, it makes a great month to do it.
Yeah, everyone build a badge.
Alvaro
This could
says
be a badge.
Alvaro says he promises to do a Microsoft CircuitPython Day next year, so we'll definitely have
Interesting.
something
Great,
else.
yeah. And we've had in other years, was it last year or year before, there was like a CircuitPython kind of workshop in India, I think, on CircuitPython Day, or
Yeah, I think so.
yeah. So if
It
you want
wasn't.
to do some local events,
Yeah,
yeah.
my local makerspace is actually doing a CircuitPython Day event this evening.
Cool.
If you're in the Detroit area, i3 Detroit is doing CircuitPython Day event. There's Q&A, demos, and just opportunities to tour the place and learn more about CircuitPython. So that was excellent to see as well. And I had nothing to do with that. They reached out to me to let me know that it was happening. So that was also excellent. All right. Well, I think we're good to go. I want to say, since I'm not going to get another opportunity, thank you to everyone who participated in CircuitPython Day. It's been amazing. I'm really glad that everything has worked out. Thank you to all of our hosts. Thank you to all of the folks that participated in different streams. Thank you to our community for making all of this possible. We say code plus community equals CircuitPython, and we mean it.
We mean it.
We can build code all day long, but without the community to contribute and be a part of it and use it, we wouldn't have what we have today. So thank you to Paul Cutler for doing the introduction. I did not have to do that either. And next up is going to be Foamy Guy's Game Jam live stream, where he's going to build a game using CircuitPython and hopefully have working code by the end of the stream. And all of that'll get posted on GitHub. So if you're interested in looking into that after the fact, all the code should be available. So thank you so much to everyone. I can't express that enough. I hope that the rest of your CircuitPython day is amazing. And please feel free to email us with your experience if you feel up to it. CircuitPythonDay@adafruit.com is available. Won't go away. So if you want to let us know how it went for you or anything you'd like to see next year, feel free to reach out. And finally, we do a call for what folks want to see out of CircuitPython at the beginning of every year. And we talked about doing it more than once a year. So I think CircuitPython Day is an excellent time to put that out there. It won't be nearly as official. We probably won't aggregate all the posts this time as we usually do at the beginning of the year. But if you have ideas or concepts or things that you would like to see out of CircuitPython, or let us know what has been great for you and what hasn't worked out for you, feel free to email CircuitPythonDay@adafruit.com with a post or a gist or any kind of way to write down what it is that you want to see or have seen, etc., and let us know. It's always really great to hear from the community, and I think folks don't always realize that we don't mind hearing from you all year long. So we put out these calls so that people know. So feel free to send that in. It's not required, obviously, but we would love to see where things are at for you in CircuitPython as we're moving towards version 8 and so on. So thank you again. Let's blink an LED. There we go.
Right.
I got mail. And now I don't. And with that, I will go ahead and wrap this up. Thanks again to everyone who watched, and thank you, Jeff and Dan, for joining me once again this year for another amazing chat.
All right. It was fun.
All right. So thank you, everyone, and hopefully we will see you next year.